Dear students, in last class we studied measurement of high voltages using spear gap instrument. In today's class, we will discuss measurement of impulse current by using Rogowski coil. The figure here shows the circuit diagram of Rogowski coil. Here you can see a toroidal coil having non-magnetic core. Through the axis of the coil and perpendicular to the plane of the coil, a current carrying conductor passes. Through this conductor, the impulse current under measurement passes. Due to the mutual inductance between the current carrying conductor and toroidal coil, EMF will be induced, and that EMF induced, which is denoted by Vi of t, is given to the RC network through coaxial cable or delay cable having surge impedance of Z0. Here Ri is the cable terminating resistance and its value is equal to Z0. Ri equal to Z0. The voltage across the integrator circuit having R and C components in it is measured by vacuum tube voltmeter, which is not shown here, and the voltage measured is denoted by Vm of t. That means Vm of t and Vi of t are time dependent values, or they are functions of the time. Now we will write about the Rogowski coil. Rogowski coil is the coil which is wound on a toroidal shaped non-magnetic core. Figure above shows such a Rogowski coil. A current carrying conductor is placed coaxially. That is, if the coil is supposed to be on the surface of paper the current carrying conductor will be normal to the plane of paper. The induced voltage between the end terminals of coil is transmitted to the integrating circuit. Here I said integrating circuit is having R and C components, but it may be op-amp integrator also. Next we will see the principle of working of Rogowski coil. Principle of working principle of working of Rogowski coil is based on mutual induction or transformer action. When current through current carrying conductor changes, the voltage is induced across the coil due to mutual induction. Let I of t is current flowing through the conductor, that is current to be measured. M is equal to mutual inductance between current carrying conductor and toroidal coil. The voltage induced that is Vi of t is given by M into di of t by dt, that is mutual inductance into the rate of change of current. We can rewrite the above equation as Vi of t into dt is equal to M into di. So we'll put here therefore symbol. The number of turns in the coil is chosen to have sufficient induced EMF in it. Output signal is given by Vm of t equal to one by RC into integration of input voltage with respect to time from 0 to t. We are integrating input voltage because we are measuring output voltage across an integrator circuit. One by RC into integration of Vi of t into dt, but Vi of t into dt we have written as is equal to m into di. We can substitute m into di in place of Vi of t dt. Then we get 1 by RC integration from 0 to t of m di. And it can be written as m into I of t after integration from 0 to t divided by R into C. What is this? This is measured voltage Vm of t. So from this equation we can see that from above equation measured voltage Vm of t is directly proportional to the impulse current under measurement, that is I of t. One by Cr is called factor of scaling. Though we are measuring here impulse current, for calculation purpose we assume that impulse current varies sinusoidally. That is, we extend the impulse current waveform in this way. Time here, and this is I of t. It will be the time required to attain maximum value. If the time period of this sinusoidal signal is capital T, then time required to attain the maximum value will be T by 4. Here Im is peak value of the impulse current. We know that there exists relationship between frequency and time period, that is f equal to 1 by t and omega equal to 2 pi f. Now we will solve one example on Rogowski coil. Also you have to remember here one more important relationship, that is 1 by RC is equal to omega by 10 into pi. A Rogowski coil is to be used for measuring the impulse current of 10 kiloampere having a rate of change of 10 raised to 11 amperes per second. The current is read by a VTVM, that is vacuum tube voltmeter, as a potential drop across the integrating circuit. Evaluate the value of mutual inductance and capacitance to be connected if the meter reading is to be 10 volt. For full scale deflection. For full scale deflection, resistance in RC network is of 2 into 10 to the power 3 ohm. First we will write all the given information. Solution. Current to be measured is 10 kiloampere. Di by dt is given as 10 raised to 11 ampere per second. Vm is given as 10 volt. And resistance in RC network is 2 into 10 to the power 3 ohm. Here we assume that the impulse current varies sinusoidally. And the maximum current Im is equal to I is equal to 10 kiloampere. To reach this current, T by 4 second of time is required. And in this region, that is from 0 to T by 4, the current will be changing with a rate of 10 raised to 11 amperes per second. That means for the current to reach 10 kiloampere value, the time required, that is T by 4, may be calculated as T by 4 is equal to 10 kiloampere by 10 raised to 11 ampere per second. That is equal to 10 raised to minus 7 second. Therefore, time period capital T is equal to T by 4 into 4, that is 4 into 10 raised to minus 7 seconds. Hence, omega may be calculated as 2 pi f that is equal to 2 into pi into 1 by 4 into 10 raised to minus 7. That is radians per second, which becomes equal to 0.5 into pi into 10 raised to 7. Radians per second. Given maximum reading of the voltmeter Vm of t equal to 10, and we know the relationship between mutual inductance, time constant Rc, and the current under measurement, that is m by r into c into I of t, or simply I. Substituting for the value of r, we get 10 equal to m by 2 into 10 to the power 3c into 10,000. Let us call this as equation 1. Further simplifying, we get m by c is equal to 2. Since scaling factor 1 by Rc is equal to omega by 10 pi, substituting for R value and omega value and then simplifying, we get 1 by 2 into 10 to the power 3 into c equal to 0.5 into pi into 10 to the power 7 whole divided by 10 into pi. Here pi and pi may be cancelled, and now we can obtain the value of c by further simplification. The c value becomes 10 raised to minus 9 farad. We have obtained m by c is equal to 2. Therefore, m is equal to 2 into 10 raised to minus 9 Henry. So in this way we can obtain the values of c and m.